Hello class, this is a college algebra video. Today I'll be doing section 4.2, which is all about inverse functions. I'm just going to solve a few problems in real time. All right, let's begin. So here is the first problem. We want to verify that these two functions, f and g, as such, are inverses of each other by showing the composition. F of g of x is equal to x, and then the reverse, g of f of x equals x. Typically, if you can do one, you can do the other. So I'm only going to show this one here. You can do this one later if you want, for fun. And then also I want to state the domain of f and g. So as I'm filming this, this looks upright, but I notice sometimes my videos, you got to stand sideways to see. So let me turn the camera around just in case that helps. Okay, so here again, there is question number 1, and I'm going to solve it right now. So here we go. I'm going to first state the domain of f and g. I'm going to do that orally. So if you look at function f, which is 2x plus 3 over x plus 4. The domain of f is going to be all x except negative 4, because if x is negative 4, we're dividing by 0. So the domain of f, let me write it down right here. Domain of f is the set of all x such that x does not equal negative 4. And the domain of g, let's do that, is the set of all x such that x cannot equal, and what do you think? Yeah, if x is 2, you're dividing by 0, so it's going to be all x except for 2. So let's write our answer like that. That's the domain of g. The set of all x such that x does not equal 2. That's set notation. I could also write it in interval notation. I'll do that right above the domain of g. So it's going to be from negative infinity to 2, union 2 to infinity. So that would be the interval form. So either way is fine. Notice I use parentheses because 2 is not allowed. So you use parentheses as opposed to brackets. They mean the same thing, the set notation and the interval notation. Okay, let's now, they tell us that these are inverses, f and g, so we just want to show or verify that's true. And the way we're going to do it is by doing this composition, f of g of x equals x. Okay, I'm going to turn the camera the other way just in case this is wrong for you. Okay, so here's my work. I want to show f circle g of x. I want to show that's equal to x. This composition will always equal x when f and g are inverses of each other, as for this problem here. So I always like to first write how this is defined. F circle g of x is defined as f of g of x. These always get hooked up, these last two letters. And this is out in front, so it's f of g of x. Then what I like to think about is do the work in the parentheses first. So let's rename g of x as this function right here. So rewrite your f, but now, instead of writing g of x, let's write what it is. It's 4x minus 3 over 2 minus x. Remember, we want to get x for our final answer. If we do, that means f and g are inverses. But then you want to make extra sure by doing the opposite, going g of f of x. And I'll leave that as a homework exercise. So what does this mean? We want to find f of this function here. So what this means is you go to your function f, which is right over here, and wherever you see x's in your function, wherever you see x's, you're going to write this whole expression, f of this. is going to be 2 times that plus 3 over that same expression plus 4. So here we go. I'm going to write 2 times, and then in place of this x, I'm going to write this expression, which is 4x minus 3 over 2 minus x. So let's see, did I do that okay? Let's see, yeah, I think so. So it's going to be 2 times 4x minus 3 over 2 minus x. Good, that looks good. And then don't forget you got to write the plus 3 because of this. Plus 3 is just plus 3, it's a constant. So it's going to be 2 times my input plus 3. And there it is, 2 times my input, which is right here, plus 3. And that's going to be all over. Instead of writing x plus 4, wherever I see an x, I write this input instead. So in place of x, let's write 4x minus 3 over 2 minus x. And then from there, let's see where we are. Sorry, I got to write the plus 4 because that's just a constant. So plus 4. Okay, so from here, we want to simplify. So I'm going to multiply this 2. Remember, think of 2 as 2 over 1. So the 2 multiplies the numerator, but then 1 multiplies the denominator. So 2 times the 4x minus 3 is going to be 8x minus 6 over the 2 minus x. Let me write that down. So I'm going to write 8x minus 6 over the 2 minus x plus the 3. That's going to be all over. This is going to equal. And then I've got my denominator. I'm just going to keep it as it is. 4x minus 3 over 2 minus x plus 4. So let's simplify that now. This is called a compound fraction because my numerator has a fraction, my denominator's got a fraction. So luckily the denominators are the same. So this is going to be easier than if these denominators were different. All I'm going to do is multiply this whole numerator and the whole denominator by 2 minus x over 2 minus x. Because isn't that the LCD of these denominators? What's the least common denominator of 2 minus x and 2 minus x? 2 minus x. So here's the way we can simplify this compound fraction. Multiply the whole numerator by the 2 minus x and the whole denominator by the 2 minus x. I'm allowed to do that because this is just another name for 1. 2 minus x over 2 minus x. That's another name for 1. So I'm going to get an equal value. So this is going to equal, so I'm going to distribute this 2 minus x over this plus sign. Isn't 2 minus x times this first term just going to be the numerator 8x minus 6? Because the 2x minus x cancels with this 2 minus x. So I'm just going to write 8x minus 6. That takes care of the 2 minus x times the first term, plus, and now we got to distribute. So this 2 minus x also gets multiplied by the 3. So I'm going to take my time here and just write 3 times the 2 minus x. It's good to show every step, especially if this were a minus sign. You got to worry about signs, so you don't want to do too much at once. Okay, over, and now when I multiply the denominator with this 2 minus x, do you see how the 2 minus x cancels for this first term? So it's just going to be the numerator 4x minus 3 plus, and then the 2 minus x multiplies with the 4, which I'll just write as 4 times the 2 minus x. Okay, so this is going to equal, and now I've got 8x minus 6 plus, distributing the 3, I get 6 minus 3x. 6 minus 3x all over, my denominator is going to be the 4x minus 3 plus, and then distribute the 4 for 8x minus 4x. So plus 8x, I'm sorry, plus 8. 4 times 2 is 8. So just plus 8 minus 4x. Minus 4x. So again, that denominator is 4x minus 3 plus 8 minus 4x. So this is going to equal, let's combine like terms. Look at this, the minus 6 cancels with the plus 6. 8x minus 3x is 5x over, and then the 4x cancels with the minus 4x, and then negative 3 plus 8 is 5. And lo and behold, wahahaha, what is 5x divided by 5? It's x, exactly what we wanted. Because the 5's cancel. So you're just left with x. So we're done with that first problem. We verified at least one way we did it. I've shown that f of g of x does equal x. And again, you could do the reverse, g of f of x, and you should get x again because they are inverses of each other. So that concludes problem 1. That was a long problem. Okay, and now let's go to the second and final problem. Let me turn it around. The function f of x equals 3x over x plus 2 is 1 to 1. That means that the function has an inverse. So we know this function has an inverse since they tell us it's 1 to 1. So we want to find the inverse function. And I don't know if I'll have time for a domain and range because this video is already going on 12 minutes. So I'm just going to find the inverse. So 3 steps to finding an inverse. Here are the 3 steps to find an inverse. Step 1 is to replace f of x with y. So I'm going to write y equals 3x over x plus 2. Step 2 is wherever you see y, you write an x. Wherever you see x's, you write y's. You interchange. So step 2 for finding the inverse is interchange x's and y's. So I've got x is equal to 3y over y plus 2. Think of x as x over 1. That way I can just set the cross products equal. Okay, and now the final step to finding inverse is to solve for y. Solve for y. So I'm going to set the cross products equal. 1 times 3y is 3y. And that's going to equal x times y plus 2. Okay, so now I've got 3y equals, distributing the x, I get xy plus x times 2 is 2x. So we want to solve for y. I just cannot divide both sides by 3, as you might think, because, when I divide, but if I divide both sides by 3, wouldn't y be by itself? The only problem is, if you're solving for y, you cannot have y on the other side of the equation. So since I'm trying to solve for y, here is what you must do. Get these y terms on the same side. Since I've got the x term on the right side of the equal sign, I'm going to subtract xy to each side. That way, both y terms will be on the left side. So subtract xy to each side. And then I get 3y minus xy is equal to, and I'm just going to write xy plus 2x. I'm sorry, the xy cancels with the minus xy. So this is just going to be 2x is what I have there. Sorry about the sloppiness. 2x. And now comes the great move. How do I solve for y? By doing this great move. Take out a y from both of these two terms. That's why we wanted the y terms together. So go y parentheses. I'm factoring out the y. And I'm just left with 3 minus x equals 2x. Now I can solve for y by dividing each side by 3 minus x. So for my final answer, I get y equals 2x over 3 minus x. This is the inverse function. If you want to be fancy, you could write it like this. Because this y is the inverse, you can write f inverse, which is the symbol for f inverse. F inverse of x. You don't have to do this final step, but it's nice. So f inverse of x, since y is an inverse function, instead of writing y, you can write f inverse of x is equal to the 2x over 3 minus x. Let me turn my camera around. So, oops, let me turn it around again. Okay, so there's my final answer. F inverse of x equals 2x over 3 minus x. And that's all we have time for. Sorry for this long video, and goodbye.